In this program, we will travel through the life cycle of a star, beginning with their miraculous birth and ending with their ultimate destruction. In space, large clouds made of dust and gas, known as nebulas, contain hydrogen and helium. Within these, stars are born. In some regions of a nebula, gravity compresses the dust and gas together, which forms a protostar. There are different types of nebula. An emissions nebula has a bright glow due to its gas being energized by the star's form. An example of this is the Orion Nebula. When starlight reflects off the dust grains, this is known as a reflection nebula. Some can be found surrounding the Pleiades cluster, a group of 7 stars on the shoulder of Taurus. Dark nebulas contain dense hydrogen clouds which absorb the light trying to pass through them. The Horsehead Nebula in the Orion constellation is a dark nebula. Although all of these sites are visible from space by telescopes, some structures are visible from observatories such as Mauna Kea in Hawaii and the Large Island, which brings excellent views because of the low density of the air found in the mountains where observatories are. A protostar is a forming star. When a gravitational centre forms in a nebula, atoms are pulled into it. These falling atoms will increase in speed and collide with other atoms, resulting in the centre heating up. This process of collision and release of heat is known as accretion. An equilibrium must be maintained between gravity pulling atoms into the centre and gas pressure forcing light and heat away. If equilibrium cannot be sustained, then the star will die. The main sequence is the longest phase of the star cycle. The star is a hot gas ball that produces its own heat and light due to nuclear fusion occurring within it. The temperature of the surface of stars can range from 2,000 degrees to over 30,000 degrees. Inside the core, hydrogen fuses into helium. Stars spend most of their lives doing this. Once the hydrogen supply is exhausted, the helium is fused into carbon.
When the core has run out of helium fuel, it maintains equilibrium by contracting to initiate the burning of carbon. This is known as a red dwarf, a cool and faint star, roughly 1/10 the mass and diameter of the Sun, and a slow burner. Examples of red dwarfs are Proxima Centauri and Bennu star. Neutron stars, as their name suggests, consist mostly of neutrons and are products of a supernova explosion. When protons and electrons combine, they are typically very dense, usually with a mass 3 times greater than the Sun, with only a diameter of 20 kilometers. If the mass was any greater, the gravity would be strong enough to shrink it into a black hole. Pulsars are fast-spinning neutron stars.
This type of star is the smallest and last star in the cycle, weighing a similar mass to our Sun as it does now. Our Sun will become a white dwarf at the end of its life, while becoming a structure of similar size to the Earth, and drastically falling in temperature from 150,000 Kelvin to 3,000 Kelvin. When a star dies, it goes quite literally with a bang. A star erupts into a large explosion which can be brighter than over 100 million suns for a brief amount of time. A supernova. A supernova is a huge explosion, ending the star's seemingly endless life and resulting in a bright equivalent to 100 million suns emitting light in a short amount of time. There can be 2 different kinds of supernovas. One occurs when a gas from a star falls onto a white dwarf, resulting in it exploding prematurely. The other occurs in stars where they are over 10 times larger than the Sun, when they experience unexpected nuclear reactions. The products of a supernova are neutron stars, black holes, and supposedly elements heavier than hydrogen and helium.
The final stage of a star's life is when it becomes a black hole. Black holes have such strong gravitational pull, nothing can escape from them, including light. The density of the matter in the black hole cannot be measured due to black holes being so distort space around them.
A red giant is a bright star of enormous size and surface temperature of about 2,000 to 3,000 degrees, cooler than the surface of the Sun. They can have diameters ranging from 10 to 100 times that of the Sun, which is 1,391,000 kilometers. They are created when a star starts to run out of hydrogen at its center. Their high light intensity is due to their size. Gravity causes the core to contract to maintain equilibrium, causing the atoms to become more compact together, resulting in the outer shell expanding to help heat escape into space. The nuclear fusion releases more energy burning helium than in the main sequence, causing a bigger and more unstable star. Red giants with diameters of 1,000 times that of the Sun and light intensity over 1,000,000 times brighter than the Sun are called supergiants.
In 1910, Enya Hertzsprung and Henry Norris Russell introduced the Hertzsprung-Russell diagram, which had shown the temperature of a star against its luminosity. They had discovered a slight trend between the variables for main sequence stars. The red giants and white dwarfs are other types of star which had shown up as a slight trend. However, the other types of star were less obvious on the diagram.
And that is why I love physics.